Dear students, through this video, we'll learn a problem on bivariate normal distribution. Look at the problem. The problem is using MGF of two variable bivariate normal distribution. Find a marginal probability density function f of x and f of y of a bivariate random variable x and y by using MGF. And second part is prove that x and y are independent if and only if rho is equal to 0. That is, rho denotes correlation coefficient here. That rho denotes the correlation coefficient here. Find the distribution of x plus y. Finally, find the conditional PDF of f of x given y and y given x. That's also given. We'll go for the solution now. The first part A, the question is you have to find the marginal distribution f of x and f of y. For that, I will consider the bivariate normal distribution MGF, moment generating function. The moment generating function of the bivariate normal distribution is m of t1 comma t2 equal to e power t1 mu x plus t2 mu y plus 1 by 2 into t1 square sigma x square plus 2 rho into t1 t2, 2 rho into t1 t2, sigma x sigma y sigma t2 plus t2 square into sigma y square. This is already known value, but to neglect on one variable because they are asking what is the value of f of x, that is conditional marginal distribution of one variable. So therefore I am planning to neglect this variable. To neglect this variable, I want to make it that t2 is equal to 0. t2 equal to 0 and the t1 is replaced with t because if it is one variable, no need of suffix t1 t2. That's why I changed it. That is the change I made. That is, so as I told earlier, that t1 is changed as t and t2 is 0. If you are replacing, it becomes t and it becomes 0, and this becomes t1 square. Sorry, it becomes t square, and this becomes 0 because t2 is 0, and this also becomes 0. Therefore, I have two term only in this. One is this term and one more is this term. Therefore, what we can have here means m of t comma 0 is equal to exponential of the term what we have here, that is here, and one more term, this should be appeared here. And what we observed here, this is nothing but the moment generating function of x with respect to t. If the moment generating function looking like that, means x follows the normal distribution with the mean mu and variance sigma square. That is the meaning, and especially the mu is mu x, mean is mu x, and variance is sigma x whole square. If it's so, you know what is the marginal distribution. The marginal distribution is looking like that because one variable already studied. The marginal distribution is for the corresponding function is fx of x is equal to 1 divided by square root of 2 pi into sigma x exponential of minus x minus mu x whole square divided by 2 into sigma square. In the similar way, if you want to neglect the first variable, earlier I replaced this one as t and this one as 0, but now I am replacing this one as t and this one as 0. Then the first variable is neglected and the second variable you have, and then you got the term like this, and the corresponding the marginal distribution must be obtained here. So we proved what is a marginal distribution for x and marginal distribution of y, and we showed if in the bivariate the marginal distributions are univariate functions. The next part, that is second question. The second question is prove that x and y are independent if and only if that correlation coefficient rho is equal to 0. Okay, just look in the first equation. In the first equation, that is MGF of two variate, in that rho equal to 0 means what happens? Just you can think, it is 0 means this term doesn't appear. Then I have a term 1, 2, 3, 4. So I will combine like that. This is the first term and this is the second term, and this is a third term, this is a fourth term. I am combining first and third term and second and fourth term, and I am writing as an exponential. That's my plan. Okay, look at here. If you are doing like that, means I got a first term and the second term, and this is a third term and fourth term. It can be written in the form of, you may write this one as I am writing here. It is better. It is equal to exp of mu x t1. That is the first term. This term, okay, and this term I am taking in the next, that is plus t2 square, sorry, t1 again, t1 square into sigma x square divided by 2. This is into again exp of the second term. The second term is mu y into t2. Fourth term I am writing now. The fourth term is sigma y square into t2 square, and divided by 2 is there if you are multiplying in. Yeah, what you are observing here, it is a moment generating function of one variable. It is a moment generating function of one more variable. That is looking like this. What it shows means I have a moment generating function of the multivariable t1, t2, that can be written in the form of the marginal distribution of t1 into marginal distribution t2. So it shows our marginal distributions can be written in the form of m of t1 comma t2 equal to m1 into m of t1 into m of t2. Then you can conclude x1 y are independent. The reverse process, if x and y are independent, imagine if x and y are independent means you can write the marginal distribution in the form of, sorry, the joint distribution in the form of the marginal distribution multiplication, that is m of t1 into m of t2 you can write. So therefore that should be rewritten in the form of m of t1 comma 0, m of t2 comma 0. Then the corresponding the m of t1 comma 0 is representing this one, and m of t2 comma 0 is representing this one. Sorry student, here you have one mistake. It is not, it is 0, it is t2. Actually you have to write like it is 0 and this must be t2. Okay, if you are writing like that, if you are merging this two, we are getting this equation. What this shows, our moment generating function is having this expression. So comparing to the equation 1, one term is missing, that is the row term is missing. So it is happen whenever rho equal to 0. So then we shown the rho is equal to 0. Yeah, in this result we concluded if rho equal to 0, rho equal to 0, that is the correlation coefficient 0, then x and y are independent, and if x and y are independent, then rho is equal to 0. So vice versa we proved. The C part is we have to find the moment generating function of x plus y, okay, first. So why we are finding that one means, so the question is what is the distribution of x plus y? I want to find the mean value and variance value, so that's why I'm going x plus y. So x plus y is needed means I will start with the moment generating function of x plus y. It can be written like that. If you are expressing that one in this form, that is a t into x into t into y, uh, it should appeared like that. It is a moment generating function of t with the t, that is t comma t. Yeah, so we know already the bivariate moment generating function if it is t1 and t2, but it is t1 is t and t2 is t. So then you can express with the help of the equation number 1. Equation number 1 already we expressed what is a moment generating function, and the t1 t2 is replaced as tt. So then in the both t is taken common, and here also the both t is t square. Everywhere t square is there, t square is there, and here also t square is there, that is taken common. What we observed here, I am replacing this 2 as mu and this bracket as sigma square. If we are replacing like that, it is appearing, this term should appear as term can be, that is, this entire term can be written as exponential of mu t plus 1 by 2 into sigma square t square. Yeah, actually this is a moment generating function of one variable that you have. So therefore, what we concluded, the mu value, it is a mu value. The mu value for our variable is what? X plus y is nothing but mu x plus mu y, and the variance value of our variable is, this is a term, the term is sigma square is equal to sigma x square plus 2 rho into sigma x sigma y plus sigma y square. Finally, we want to find the conditional distribution. Actually, the conditional distribution part we don't want to do, because already we have in the problem number 1 and the page number 8, we have to prove the same thing here also. So that's why I'm not repeating that one. So students, I'm advised to go through the problem number 1 in page number 8, and there we proved already how to find the conditional distribution. Thank you, students. Finally, we can conclude, and x given y equal to x is normal variate with this mean value and this variance value, and y given x equal to x having a normal variate with mean value is this one and variance value is this. Thank you, one and all.